This lesson will focus on quantitative sampling, probabilistic methods. There are a number of different types of probabilistic sampling. As we recall from the previous video, probabilistic sampling is that type of sampling which ensures that either randomness or chance are the determining factors in who becomes part of the sample. The basic idea is that everyone has a more or less equal chance of getting into, from the population, has a more or less equal chance of being part of the sample. So for that reason, I show a game of chance, a roulette wheel, where supposedly every single number around here has an equal chance of being selected. The idea in this game is that they put a ball on, they spin this around, and then they put a ball that rolls around the numbers here, and then it should fall into one of these slots, and people gamble to decide which of the numbers it is, for those of you who have not been to a casino. There are four different types of probabilistic sampling: simple random sampling, systematic sampling, stratified sampling, and multi-stage cluster sampling. We will go through each of the four types one by one. The first and the easiest one to understand is simple random sampling. Simple random sampling means that every single person in the population has an equal chance of being selected for the sample. So a classic example of this is having a class, and everyone writes their name down on a piece of paper, and then everyone puts that piece of paper into a hat, and then you randomly draw the names out of the hat. The idea is that everyone should have an equal chance of being selected. Of course, in more modern statistical and research institutions, things have become much more sophisticated, and now, most frequently, people use computers to determine who is selected. Because as you can imagine, using a hat, whatever name happens to be put in on last, and so forth, there might be a number of factors that might prevent people from having a truly equal chance of being selected. But now there are a number of websites, such as random.org, that you can go to that can find as close to true random selection as possible. The next form of sampling is called systematic sampling. In systematic sampling, the idea is that you have a whole list of people, or whoever your unit of study is, and you randomly determine some number, and whatever that number is, you will select every nth person. So for instance, it's much easier to show than to explain. Every nth individual is selected in systematic sampling. So for instance, I might have a population of 12 people, and I want to select randomly a number of people from this. And I randomly pull up the number 3, which means then that I will start, wherever I start, I will select 3 every third person. Usually then you also determine randomly where you start as well. So in this particular case, we start at the number 2, and then 2 plus 3 means we take the 5th person, plus another 3 we take the 8th person, plus another 3 we take the 11th person. And this way we'd have systematically sampled. Because you're randomly determining where your start point is and however many people are between the selection, everyone still has an equal chance of being selected. It's particularly useful if you have something like a phone book or a list of names from an organization and you want to select from them. Stratified sampling is used to ensure that subgroups within the population are adequately represented in the sample. This can be achieved in at least two ways. Either the ratios of the subgroups of the populations will be reflected in the sample. So for instance, our example earlier in the previous video about having 75% of our sample being of the population being female, and then our sample should reflect that population in terms of gender. So we would also want the sample to have 75% of it be comprised of females. Another way that it can be achieved is that all the subgroups will have equal numbers of people to improve statistical accuracy of comparisons between groups. So for instance, in counseling, there really is an imbalance for more females than males, but perhaps for whatever reason you want to do some sort of statistical comparison between males and females. For that reason, it's much easier to do those comparisons if the numbers between the samples are equal. And so we might try to ensure then that our sample has 50% of males and females. Stratified sampling comes from the term strata. So first, you have to determine what it is that you're interested in, and it's usually used, stratified sampling, to ensure that there's an equal representation of a subgroup, which is usually done because you are worried that somehow one of these groups will confound the results if they're not accounted for. So first you want to identify the variable of interest. For instance, you might look at race. Next, you would identify the different levels, also known as strata, of the variable in the population. So just as one possibility, we might come up with these four categories of race: Black, Latino or Latina, white, and Asian. Once we've identified the different strata of the variable in the population, we might then sort individuals by the strata into different groups. And then, from each of those groups, we would use simple random sampling, or SRS, to select individuals from each stratum. Stratum being the singular version of strata. So the idea then would be that from the subgroup of individuals who identify their race as Black, we would want to use simple random sampling from that subgroup to determine which individuals would be in our sample. We would then do the same thing for Latino, Latina, for white, and for Asian. And in the end, we would hopefully have a sample that reflects the characteristics of the population in some sort of even capacity. Multi-stage cluster sampling is a very big term, and it's used most often for very large groups. So whenever you have an enormous population and you want to have some sort of probabilistic sample drawn from it, multi-stage cluster sampling is often the best way to go about it. So multi-stage cluster sampling, the idea is that you create clusters, and from those clusters you then randomly sample. And then once you've randomly sampled from those clusters, you create new clusters and randomly sample from those, and so on until you achieve this sample with the unit of study that you desire. So an example will help clear this up. Let's say that you're interested in studying Manhattan, people who live in Manhattan. So Manhattan is an enormous borough. It has 1.6 million people that live in it. That's a lot of people to try to randomly sample. So one way to go about doing it is you decide to cluster Manhattan into different neighborhoods. So starting at the top, we have Inwood, Fort George, Washington Heights, and so on all the way down. And each neighborhood has however many tens of thousands of people. And then you decide that you're going to randomly sample 3 of those neighborhoods. As you can imagine, each of these neighborhoods really is, you could think of it as a cluster of people, right? So you decide to randomly sample 3 of these neighborhoods. And these are the 3 that you come up with: Harlem, Yorkville, and Chelsea. And then within each of these neighborhoods, you decide to further cluster by street. So in Harlem, you randomly sample 3 streets from each neighborhood. So from Harlem, you find West 115th Street, West 118th Street, and West 121st Street. From Yorkville, you randomly sample the different streets and you find these 3 streets: East 92nd Street, East 84th Street, and East 82nd Street. And then from Chelsea, you find these 3 streets: West 16th Street, West 25th Street, and West 29th Street. Then, from each of these streets, you decide to sample different apartment buildings. And so let's say on West 115th Street, you decide to sample 3 different apartment buildings that are located on that street, or 2 different apartment buildings located on that street. And you come up with 229 West 115th Street and 83 West 115th Street. And then you do the same for the other 3 streets in Harlem. You do the same for the 3 streets that you selected in Yorkville, and so on in Chelsea. Here then you have 3 different stages at the neighborhood level, the street level, and the apartment building level. And each of those then can be considered clusters. So that's why it's multi-stage cluster sampling. You could go even further. Within each apartment building, you might decide to look at different units, and then you might select people within those units. So you could have a 5-stage cluster sampling process. But in this way, everyone would have had an equal opportunity that was in the population of Manhattan to become part of the sample. This is a list of the 4 subtypes of probabilistic sampling with a brief definition for your reference and a brief example for your reference. In the next lesson, we will go over non-probabilistic sampling.